Okay, this is lesson 6, features of graphs. So we've got a graph here, and here's the situation. We know that Diego is walking home from school at a constant rate. The graph represents the function d, which gives his distance from home. And I'm just going to underline that distance from home in kilometers, m minutes since leaving school. So you'll notice that I've given you the function name, again, is d of m. And remember, please, that m is the input. And the input in this case is minutes since leaving school. So let's just take a look here. So we've got this graph. And I know from the input that the x-axis right here is minutes. And it's minutes from leaving school. From leaving school. All right. So again, notice that minutes is increasing. It's going up +4 each time. All right, these are just things I want to point out. All right, so it sounds also like this here, distance. This is distance. Oops. And distance depends on minutes, right? So the distance is in kilometers or kilometers. So that's what I know. So I'm just, again, and I'm noticing here that the graph starts way up here and goes down. All right, so these are just things I'm pointing out that I want to make sure that you're aware of and, in a sense, how to read it. All right, so let's just make sure I put this in right here. We know that this is distance, this is minutes. We've got our function d of m. All right, so what we are supposed to do is use the graph to estimate or to find the value of these function notations. So let's remember the input. Let's go back here. The input is m, d of m. So I'm going to go right here, and I know that this is 0 minutes. All right. So 0 minutes, use the graph. So I am looking for the distance at 0 minutes. So here's 0 minutes right here. So what I'm going to do is I'm going to follow this all the way up till I find where the graph is, right there, where the line is. And what is the line? What am I pointing to? What did I draw a big circle around? Right there. So what is that value right here? What is this value? Well, I know this is 2 and this is 2.5. So it's about halfway between 2 and 2.5. So I'm going to say this is 2.25 kilometers. All right, so that's the distance at 0 minutes. All right, so now let's find d of 12. So again, this is minutes. So again, this time I'm going to actually erase this, and I'm going to use red, and I'm looking for 12 right here. So at 12 minutes, what's the distance? So I'm going to go up here till it reaches the black line, and then move it all the way across. So if I know that this is 0.5 and this is 1, that's a little bit more, I'm going to say at 12 minutes, how far away is he? He is I'm going to say approximately 0.75 kilometers. So you can see his distance at 0 minutes. He was 2.25 away. at 12 minutes, he's getting closer to where he's going. So just something to think about. All right, next one, let's see, is, all right, so this next one asks us, what is the solution of d of m is equal to 1? So I am looking right now. I want to know what are the minutes because I don't have it. So again, remember this whole thing, d of m equals 1. 1 is the output. That is my distance. So my distance is equal to 1. So what I want to know is, what is m? So m is question mark. How many minutes is m when he's 1 kilometer away? So let's go up, take a look. Oops. All right, so I'm going to go to 1, right here at my distance. I'm going to go all the way over till it hits the black line, and then I'm going to drop from that point down right there. So if this is 8 and that's 12, that means I've got there's 4 spaces. So I would say it's approximately 11. So approximately 11 minutes. It's not exact, right? Because we don't know exact. All right. How about the solution d of m? So what is that? What is d of m? Well, it's just going to be the minutes. I don't know, the minutes. And I'm wondering if I might be missing something in this, that something didn't come out. So I'm going to double check my notes real quick to make sure that d of m needs to equal something. Okay, so I looked at my notes and the 0 just didn't type in. So the last one, number 4, should say the solution to d of m is equal to 0. So again, I want to figure out, I want to know what is m. So what is m equal? Remember, m is the minutes. So at how many minutes is he when his distance is 0? So let's go back up. Okay, so I want to know when the distance is 0. So here's 0 right here. Right here, here's distance is 0. Here's 0. I'm going to go all the way over till it's right there. So I'm going to erase this just to double check. Yeah, so it's right there. So right at 20. So minutes, how many minutes is when the distance is 0? The minutes is 20 minutes. So that's what we did in class, was we read the graph on how to figure out. And I have to remember that the input is always, that's why I pointed out that m was the input. So because I have no idea what the m is right here. So if I need to figure out what are the minutes when my distance is 0. All right, so let's continue. All right, so after we did that activity in class, we then talked about some discussion questions, and it was also based on the graph. So here's the same graph, and we talked about, is this linear? And I think you all agreed that it was indeed linear. Yes, it was definitely linear. And how could we tell? Well, it was a straight line. Okay, that was important. We also talked about, or that we need to remember, that the line is going down. And if you think, I'm going to actually go back to the description. So here we go. I'm going to go all the way back to the beginning. Oops. And right here, the problem says that Diego is walking home from school at a constant rate. So at a constant rate. So that is a linear situation, especially when it's matched with the straight line. All right. Can you tell how far away Diego's home is from school? So again, if you go back, and we talked about he's walking home from school. So this means right here, he started at school and he's walking home. All right, so how can you tell how far away Diego's home is from school? Well, what you do is that you read the graph. So his house is 2.25 kilometers away from his home. All right, how long does it take Diego to get home from school? Well, if this is time 0 right there, and he starts at school, and he walks home, when he gets home, how long did it take him? If this is 0 and that's 20, if I look at the difference between 20 and 0, 20 minus 0 is 20. It takes him 20 minutes to get home from school because he lives 20 minutes away. All right. So that was reading a graph, understanding what the graph or what the story tells us about the graph. All right. Then what we did in class is we moved on into identifying features of graph. And we are going to continue to look at some features about graphs. Okay, so the things that we're going to talk about on a graph is we're going to talk about the maximum. So that's the highest point on a graph. We're going to talk about the minimum, the lowest point on the graph. We're going to talk about a y-intercept. So where is the graph touching the y-axis? We're going to talk about where the graph is increasing and where it is decreasing. And I'm going to show you this graph and do these points on the graph exactly. All right, so the very first thing we're going to talk about is the maximum point on the graph. So where's the highest point? The highest point is right here. This is the highest. This is the maximum. All right, take a look at the graph. Where's the minimum? Where's the lowest point on the graph? Right here. This is the minimum. I'm just going to abbreviate it as MIN. All right, so now where's the y-intercept? Well, believe it or not, the y-intercept is actually the highest point. So right here, this is the y-intercept. It's where the graph crosses the y-axis. All right, so now where is the graph increasing? So I want you to think about when you learned about linear graphs last year. So it is increasing. I'm going to use green. Here it is increasing right here. All right, so the green is showing me where it's going up. So right here, right here, right here, and right here. So the green is indicating increasing. So I'm just going to do it increase. All right. And then, so where is it decreasing? So let's pick another. Let's go gray. All right. Where is it going down? It's going down right here, 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 and here. So these are decreasing areas of the graph. All right. Moving on. Let's look at this one. All right. Again, we're going to identify maximum or the highest point. Right here, max. All right, what about the lowest point on the graph? Right here, lowest. That's the minimum. All right, what about the y-intercept? Right here. Here's the y-intercept. It's crossing the y-axis and look at the value of x. X is 0 there. How about the x-intercept? Here's the x-intercept right here. That's the x-intercept. How do I know? There's the x value, the y value is 0. And it's actually sitting on the x-axis. All right, where is the graph increasing? Right here. It's increasing right there. And it increases right until it gets to the highest point, and then right at the highest point, this is where it's decreasing. It's going down. All right, so now let's look at another one. So we're going to identify again the maximum, the minimum, the y-intercept, the x-intercept, increasing, decreasing, and this time we're going to add one more thing on, the constant part of the graph. Where is the graph staying the same? All right, I want you to try this on your own, right? And then I'm going to layer on and explain. All right, maximum point right here. Okay, minimum, lowest point on the graph right here. All right, y-intercept. The y-intercept right here is also the lowest point on the graph. How about the x-intercept? There isn't one. There's none. The graph, the line doesn't cross the x-axis at all. Where is it increasing? Where is it increasing? So right here. Increasing. Where is it decreasing? Let's see, what color do I want to use? Let's use yellow. Right here. It's decreasing. Ooh, missed an increasing one right here. Those two are increasing. This is where it's decreasing. Whoops, meant to make that yellow. That's where it's decreasing. And where is it staying the same? Right here. Here's where it's constant. Constant. Remember the drone and when it hovered? So there's no change here. It's constant. It stays the same. Very good. All right, let's go on. Look at another one. So now, label. This was something that you were asked to do in class. So this was the activity where you needed to label each of these points using these numbers. So hopefully you did well, but let's give it a shot. So maximum point, I'm going to put a 1 right here. Here's the maximum. Minimum, there's only one minimum here, right here. Here's the minimum. This is 2. Y-intercept, right here. This is 3. X-intercept, right here. That's 4. Increasing. So I'm going to show, there's 2 places I'm going to put a 5. Right here. This is increasing. And right here. This is also increasing. Decreasing. Let's go yellow for decreasing. Decreasing right here. So this is 6. And that's it on the decreasing. And then 7 stays the same right here. And I'll make it purple. So hopefully you've got that. And that a lot of these words are words that you should be fairly comfortable using. Maximum, minimum, increasing, decreasing, constant. So moving on. This was the summary. So again, it went over all the things we talked about. Talked about that this is the y-intercept. Right here, it's also called the vertical intercept. I like y-intercept. Makes more sense for students. It just talks about all the things that we talked about. How we can tell a story, which is what you did at the beginning when you read the graph about Diego going home from school. So don't forget, you had to do an exit ticket. That was part of this lesson. Make sure you get your homework done. All right, have a great day.